name is Samuel, and we'll be going through
The Euler method.
So firstly, take note of the assignment question. So the Euler method is a method where we can approximate the solution for an ODE equation. So we actually are given two equations: yn plus 1 equals to yn plus h, xn yn, and xn plus 1 equals to xn plus h being the step size. So we start from a starting value, and then we increment with each step size, and then we end at a endpoint. So basically what we want to find is the current points of all these step size equations, and at the end of it we can form a graph which gives us a slope, and this slope will only give us an approximation of the true solution. To note in this question, note that the starting value xy equals to 0, 1. Then you want the end value to equals to 1. So xn plus 1 equals to xn plus h equals to 1. Then we let the step size be 0.2. And note that these two equations on the left and the right hand side are equal. First unit formula, and using the initial values, we find y1, which gives us this. And then we find yx1 using the second Euler formula. Repeat that for y1, x1, y2, x2, and y3, x3, y4, x4, and y5, x5. So now we're given this collection of points mentioned. After you plot all the points on the graph, you get a slope. And the only problem with this slope is that it's only an approximation and is not the exact solution. So secondly, I did the Euler's method in Excel. So firstly, I went to make 3 columns, 1n, xn, and yn. And then afterwards, I created the h value, the step size. Then I filled in the n value, which is just the number of n. Then I initialized the initial values of 0, 1. Then if we look at the xn, I use the previous values. For the first n, xn1, I use the previous value and h. And for h, I locked it using the dollar signs. And as you can see, it copies for every single one as well. So the following one and the h. So for yn, I use the previous yn and then plus h times x divided by x squared. So I did the same thing, locking the dollar sign. And for every consecutive one, it uses the previous xn, xy, and uses the same h. And then lastly, I selected the entire table, and then I inserted a graph. Lastly, we will be doing an IVP general solution. So we're given these two equations from the beginning, and then this first equation is separable. So I separate it and I do integration on both sides. So I get this and this plus c. Then afterwards, I want to make it only just y. So I manipulate it, times 3 on the ends. Then afterwards, I just want it to be y. So I divide times 1 power 1/3. Then I sub in the first equation, x equals to 0, y equals to 1, y1, x equals to 0. So I get c2 equals to 1. And then I find the general solution. Lastly, to solve for y bracket 1, so we sub in the x equals to 1 into the equation from the general solution. Then we get 5/2 power 1/3, which gives us 1.35720. Then previously, using the Euler method, we found that our y when x equals to 1 equals to 1.319. And the Euler method and the IVP general solution do not align. There's a discrepancy of about 0.04. So I can actually conclude that the Euler method is only just an approximation. Thank you very much, and that's it from me for the Bernoulli ODE. Bye bye.